Hello everyone, so welcome back to another video. This is another MathCON problem. So this was a grade 9 question on the practice 4, okay? So we are given a parabola and the graph of this parabola is given right here. And the vertex of the parabola is on the fourth quadrant, and then A, B, C are the points on the intersection of those X and Y axis. The area of this triangle is 2√3, and what's the value of M? Okay, so, we are given the area, so we should be using this somehow, and then we know the y-intercept of this parabola is going to be this point B. So if you plug 0 for X, your y value will be just -2, right? So which is why your y-intercept is 0,82, which is point B. So 0 -2, and which tells me the distance right here is 2 units. So, and then if I kind of find this distance, right, and multiply with the height and take the half of that product, that's going to be area. So let's use that. So if I say this is like base, let's say this is A times height, which is 2 units, and divided by 2 is 2√3. So from there, so that distance from this intersection to this intersection is 2√3, okay? But keep this in mind. But at the same time, we are told this is the equation for this parabola, and then this is quadratic, we should have two solutions. I'm going to call this guy A as x1, y1, and then this guy will be x2, y2. Even though I don't really need the y values for those points, I just like to find the x1. So to get this distance, that is distance between our x coordinate and this x coordinate. So that distance 2√3, okay, so 2√3 is equal to x2 minus x1, which is the difference of my solution to this quadratic, okay? So let's say this is 5, let's say this is -3. So you get 5 minus -3 to get this 8 units. So that's basically what I meant right here, okay? But I don't really know the roots, right? So maybe I can find by using my quadratic, but let's actually find a nice result for the difference of the solution. So for a quadratic, just a reminder, when you have ax squared plus bx plus c equals 0, my solution is minus b over 2a plus or minus b squared minus 4ac over 2a. Again, this is a fundamental theorem, right? So quadratic formula. And I'm going to use this guy to find a relation between the coefficient of the quadratic with the difference of the roots. Okay, let's say x2 minus x1. So the x2 is just like, is the positive root, which is the larger one. So when you use the quadratic formula, I will just take the positive version. So minus b over 2a plus b squared minus 4ac over 2a. Again, this is my larger root because that's going to be a plus, and minus, so let me put this in parentheses, my second root will be just the minus version of this middle part. So minus b over 2a minus b squared minus 4ac. That's on the radical divided by 2a. So again, this is just additional work, okay? So for us to really understand what's going to be the relation. So that will be x2 minus x1. When you expand it, this is minus, this is also minus. When you expand, you will get b over 2a, and then this is minus b over 2a. So this guy and this guy will be 0 when you add them. And then this is a positive term, but this was negative, but there's a minus in front of that parenthesis. That will be also positive. So this guy and this guy right here will be actually the same with the sign as well. So that is 2 times b squared minus 4ac, because we have exactly 2 of the same thing, divided by 2a. And then these 2's will cancel, so you get b squared minus 4ac over just a. And this is called difference of the solution for a quadratic. Some people remember as a rule, so if you really want to do that, so that's probably up to you. So the difference of the solution of a quadratic is some people kind of make this a bit like shorter with a triangle. That's basically the discriminant of this inside, like that's inside of radical divided by a. So sometimes this is gonna be a like positive or negative. So if you want to find a positive difference, so you're probably want to place a absolute value sign. And this is a like maybe relation, I would say, between the difference of the roots and the coefficient of the quadratic, okay? But if you don't want to remember this one, don't do that. Just use this approach with your concrete numbers, okay? So whenever we're doing, you know, we do know the difference of the solution was 2√3, which is I'm going to use this one. Okay, so let me do this. So 2√3 is equal to, so that was the square root of the discriminant, which is b squared minus ac. So in our case, a is 1, the coefficient of the square term, b is m, and c is -2. And that will be b squared, which is m squared, minus 4 times a times c, which is -2. And this whole thing on the radical divided by a, which is 1. And if you square both sides, you can get rid of those radical. That will be 12 equals m squared plus 8. And if you subtract 8 from both sides, so you get m squared 4. So the m should be plus or -2, right? But at the same time, m is our coefficient right here, right? And we are looking for this guy. So I have this guy and this guy. So let's see which one actually the case, right? So we have two choices. So if you look at the m, or maybe another information of your radical, like your parabola, so you know m is actually the somehow related to our vertex, right? So and then we are told the vertex was on the fourth quadrant, so which is I didn't use that information yet. And if you remember, the vertex of a like quadratic is minus b over 2a. I hope you know why this is the case, but if you don't know, just take a look at this and the quadratic formula and see if you can see a reason for that. But minus b over 2a is the vertex, which is the x coordinates, right? So x coordinates of the vertex, I will say comma whatever after, okay? So which is gonna be y value. So I'm gonna choose this is y. And then if you plug this into the equation, you get the y value anyway. And if you look at the my b is m, which is gonna be minus m over 2a, a is 1, so that's gonna be 2. And I do know this guy is my x coordinates of the vertex. And then we are told this is on the fourth quadrant, which is obviously seen right here. So this number right here, x coordinate, is a positive. So in order for this number to be positive, so m has to be negative. So which is why we cannot take this 2. We need to take this guy as our final answer. So again, the question kind of testing a couple of skills at the same time. So if you are struggling with maybe some of the steps, it's better to review the vertex form of a quadratic, okay, a parabola, and some of the quadratic like formula approaches, and see if that makes more sense. Okay. So again, I hope that makes sense. I'll see you in the next video.